Okay, next we're going to look at specific strategies for graphing exponential functions. Always you can just use the fallback of making a table. So if I just kind of go like this, we have to remember our exponent properties. So 2 to the negative 2 is 1 over 2 squared, 1 divided by 2 squared, because that negative exponent means we have to flip it down. So this is 1/4. And then 2 to the negative 1 is 1 over 2 to the 1, or 1/2. 2 to the 0, remember anything to the 0 power is 1. 2 to the 1 is just 2, and 2 squared is 4. So there's our points. And so now I'm going to graph these. So I have -2 1/4. Well, 1/4 is a quarter of the way between 0 and 1, so it's just barely above the x-axis. At -1, I'm at 1/2, so I'm halfway between 0 and 1. At 0, I'm at 1. At 1, I go up to 2, and at 2, I go up to 4. So you end up with this curve, like this, and like this. Now thinking about this, 2 to the x power, there is no way that you could make this negative, right? 2, there's no power that you can raise 2 to that's going to suddenly make it a negative number. There's no power that you can raise it to that's going to make it 0. It doesn't happen. It's not possible. So we have what's called an asymptote, where our graph is going to get closer and closer to y equals 0, but it's never going to touch it or cross it. It's just going to get closer and closer. So this is called an asymptote, and I always struggle with spelling it, but luckily I've spelled it multiple times today, so I think I have it. Hopefully that's correct, otherwise I've done it wrong several times today. So you have this graph like this. Let's see. There's some key features on here that I want to point out. One is that y-intercept, which is at 0, 1 in this case, but generally speaking, it's going to be at 0, a. So for this equation, if I'm thinking y equals a times b to the x, I don't have an a value. So we're talking multiplication, so the identity in multiplication is 1. In other words, 1 times anything just stays the same. So we have this invisible 1 here, which is why here our y-intercept is at 1. And then we also have this point here that's important. This is always the point at 1, b, or if there were a different a value, it would be 1, ab. So here, if it's just to the first power, then we don't really need the exponent, right? Anything to the first power is just itself, so it would just be a times b, or in this case, it's just 2. Okay.